These notes are on hyperbolas. So the standard form for hyperbola looks like this. The only difference between the equation for standard form of ellipses and hyperbolas is the minus sign in the middle. That gives it a different shape. All the other numbers sort of represent the same thing in terms of graphing these hyperbolas. So let's go right to an example of graphing. So you'll recognize, if you've watched the previous video on ellipses, you'll recognize this equation is the same, except that in that video it's a plus, of course, because it's an ellipse, not a hyperbola. So my center is still 0, 0. And the distance I'm going to travel along the x-axis is 5. And along the y-axis is 3. That process starts the same. However, I'm not going to connect these 4 points to make, whoops, I went a little too far down, there we go, to make an ellipse. Instead, I'm going to use those 4 points to make a rectangle. And the rectangle I'm making, you can actually think about it as being the rectangle in which the ellipse would sit. So if I were to graph an ellipse here, I would actually connect it. It would be inside that rectangle. However, for hyperbolas, I actually need to graph this box in order to get my asymptotes. And my asymptotes, these are the lines that my hyperbola goes right up against but never reaches. Go through the corners of the box, my rectangle. So now I have two options for my hyperbola shape. I either have what we sort of, many of you will look at this and be like, oh, it's two parabolas. It's not, but it has that U shape. So either I have the U shape going up and down, or I have it going left and right. And the way I tell which direction it goes in is to look at the standard form and to see which of the coordinates, x or y, is positive. In this case, the x is positive, so my hyperbola is going to have its sort of bottom point and top point along the x-axis. And there's my hyperbola. Let's look at a second example. In my second example, we've added a twist here, of course, because we have a different center. So my center, and we've added a second twist, because remember, my center is always going to be x comma y. But if you look at this equation, which portion is written first? The y. So I need to make sure when I'm writing my center that I look at my x comma y. So my center is at 1, -2. I then am going to use the numbers underneath those two portions of the equation to determine how much left, right, up, down to go. So the first one is the y. So the y is an up-down distance that it's telling me. So I'm going to go up 4, down 4. And my x is 3, so I'm going to go to the right 3 and to the left 3. Again, if I were at this point graphing an ellipse, I would connect those 4 points and make a lovely little circular elliptical shape. But I'm not. I'm graphing a hyperbola. So I make my box so that I can draw in my asymptotes, those lines that the hyperbola approaches but never touches, which is also why I make them dotted. And then I have to decide, once I've got those drawn in, whether or not my hyperbola goes a left-right hyperbola or an up-down hyperbola. And again, I look at whatever portion of the equation up here is positive. My y is positive, so that's going to be an up-down hyperbola. So my shape, The bottom of my hyperbola or the top or the most left right or most right are always going to be on that edge of that box. So that vertex is going to always be one of those 4 dots that you drew in order to get your box. And the branches of my hyperbola should get close to the dotted lines but never actually touch them. Another task that you've done with hyperbolas is to write them in standard form. And this process is it is actually the exact same process as writing ellipses in standard form. But of course, we have some negative signs that are happening because the equations of hyperbolas have a negative sign between the x portion and the y portion, or vice versa. So I regroup my terms so that my x's are together and my y's are together. I factor out any portion in front of my x's that are not, the x squares that are not 1, and the same thing for my y's. I complete my square, remembering that of course I'm not simply adding 9 to the left-hand side, I'm adding 27. I complete my square, remembering of course that I'm not adding 1, I'm actually adding -4. I rewrite these in perfect square binomials. I simplify the the left-hand side. So -2 minus 4 plus 27 is going to be positive 21. I then divide everything by that 21. Okay, yeah, just double checking my math there for a second. I expected a slightly different answer when I had set this up, but I think that this math is actually correct. So in my first fraction, 3 and 21 simplify, reduce perfectly into 7 in the denominator. In my second fraction, it doesn't. So I am going to rewrite this one as when I simplified this fraction, I really divided 3 by 1 and divided 3 by 3 and divided 21 by 3. Here I'm going to divide 4 by 4, and then I'm going to divide 21 by 4. So I write that one as 21 divided by 4 equals 1. The last thing that your teacher may or may not have done with you regarding hyperbolas. Oh, I have a typo here. So sorry about that. This should say, of course, hyperbolas. Graphing hyperbolas with your calculator. I am again going to have to solve for y. So the first thing I'm going to do is I'm going to move over my x portion here. So I have y minus 7 squared over 16 equals 1 plus x plus 5 squared over 4. I'm going to multiply both sides of the equation by 16. When I multiply the second portion by 16, 16 and 4 can reduce, so I end up with 4x plus 5 quantity squared. Square root both sides, remembering, of course, that when I square root, I have an absolute value issue to take care of, so I have a plus or minus. And the last thing is to get y alone, so to add 7 to both sides. So again, I have 2 equations to put into my graphing calculator. I have the 7 plus this whole square root business, 16 plus 4 times x plus 5 squared. And then I have the second equation, which is 7 minus the square root of 16 plus 4x plus 5 quantity squared. And then I press graph. And depending upon what picture I get, I may have to adjust my window a bit. And here comes the shape. Now you'll notice on the graphing calculator that the graphing calculator does not draw in the asymptotes. So I don't have a full picture here, but I do know that my hyperbola goes up down because that y squared is the positive portion. I also know that my center, just to put a little side note here, is going to be -5, 7. So -5, 7. So my other hyperbola branch is up here. So I'm going to go to my window. I'm going to say that I don't need an x max of 10. Maybe I'll do an x max of 5. But I do need a bigger y max. So let's go up to maybe 30 and see what shape that gives me. There's that top branch coming out quite nicely. And there's my bottom branch coming out quite nicely. Now, of course, I could go more to the left in order to have it be a little bit more symmetric. So maybe like a -20. And this will be the last adjustment I make, but just to try to get it to look a little less. There we go. That's a lot more symmetric now. So now I can really see those two branches. And the graphing calculator doesn't do this, but you can imagine the asymptotes going sort of crossing right here in that middle. That's where they are, kind of hiding there in that graph.